Hi, this is Nissim. Today I'm very excited to show you a video about 1 billion pixels images, and I even take it a little further. Some of them is 1.5 billion pixels, like crazy amount of data. And I want to show you the way I make them. First of all, I will show you the images themselves and the zooming and the crisp and everything. Also, you will see the pitfalls in creating those images. So, first of all, let's see the first pair of images. The first pair is those images. Now, you see here above, this is the original size, and this is the 1000 plus X size. This image, the one on the left, is a 512K image. That one is around half of K. So let's zoom a little here in this part of the 1x, and you will see this spaceship in this place in this resolution. Here, let's do a little zooming. Okay, now we are not even on 100%, although in this image we are on 800%. Okay, so if I will put them almost the same size, you can see the details and the difference. Now let's do a little more zoom until we get to 100. And this is how it looks like with 100%. Now let's do 100, like zoom out. So you will see where is the image compared to the other place. And you can see the size of it and the details. Also, let's do zoom here in the bottom. You see here, I have here something very small, like a spaceship. You see here this spaceship, very small. Right now I'm on 100%. I can do a little more zoom and I will see it a little larger, but I prefer the 100%. If I will take the same place here in this image, it's supposed to be here, but sorry. It's supposed to be this, I think, this part or this dot that does not exist here. Okay, so it's super amazing to see it. Like, I love to do this action, and then you see the entire image, and you can see what zoom it did. Okay, so I can increase it a little more even if I will try, and I will show you, because this is only 1 billion pixels, and I want to show you also the 1.5 billion. So let's see the bigger image. Let me close those, and I will open the new one. Now, I just want to mention that if you don't want to see more images, the 1 billion images, the example that I just did, to continue directed to the workflow, you can see below on the timeline where I start to talk about the workflow itself. So jump there if you don't want, or continue and see some more cool images and what did I do. So let's see the next one. This is the 1.5 billion pixels. Now I will show you in different sizes, so you will see the amount of work and everything. The image on the right is the 1x, okay? So you can see that the resolution in the bottom, the zoom, it's 800, and this is what we are getting, okay? Now, this is the 9x, so I will show you now the 9. And I have better, you see, I have better resolution on the image, but still I'm getting the number 1, I mean the 100% is this size, okay? Unlike the 1x, that this is the 100%. Okay, so this is the 100 for the 9. Let's take the 144x. Now, the 144x, if I will make the zoom more and more, and let's make it to 100%, you see it's much better, but still I have missing of details, and if I will zoom more, it's a pixelite. Now, let's see the 1296x on the left. Now, let's start the zoom. Now, we have multiple versions of that one. It took me 6.5 hours to generate. Okay, this is now we are on this almost the same size, you see, but here I'm on 26%, and I can go further. And here I'm on 100, okay? And you can see the details. I intentionally made more details on the image, so you can see even small rocks here and there, okay? And let's do now a zoom out. And zoom out, okay? Now, there are amazing data here that you can see here, like, we have here some trees, very small trees. See, if I'm going to do zoom out, you can't see them anymore. Now, you can see here some artifacts on the image. You can see here some rect. Why? I try to do it in multiple versions. Now, I can get to a version that I don't have the rect at all, but it will take around 24 hours to create. And I tried that, and the computer crash, etc. But I want to show you what happened with different denoising on the upscaling. So let's move it to the right. Now here you can see the same image, same size, same resolution, but the denoise is 0.25. Now you can see the rects. I did it with the 2K on 2K rects to save time in the rendering. So the size is fine, the details are okay, etc. But I don't like it. Really, I don't like it. I can go here and see some trees also. Okay. But the rectangles are not okay. I still see them a lot. And when I take it out, you can see it even in the water, etc. So I didn't like, you need to make it, even though that image on the right is 0.1 denoising. On the left is 0.25. I think I need to do it even with 0.05. And the size of the tiles that I use, I need to make them 1000 on 1000 K on K. Okay, so it will be much better. And then you won't see that. Okay, now I will show you another image of 1 billion pixels, and you will see that there are no tiles. Now let's see another image. Now that image I generated using Flux, the original image, and then I increased it. The other ones I created using other models, but I want to get one that is more real for the creation of the upscaling. So I'm doing the image generating with Flux, and then I am doing another two upscaling, actually, with the other models that keep the Flux quality. Okay, so let's see. This is on the left, you will see the X1, and this is the image. Okay, no, so many detail. Everything is jerky and pixelized. That one is 16. Okay. Now let's do a compare between them. So this is one the 100%, and this is here the 100%. So I have much more data. You can see here reflections, much better the reflections. The data here is more crisp, etc. It look good, right? Let's see the 60 the next jump, which is the 1024, which is 1 billion pixels. Okay, that one, the 64, I multiply by 16, like 4 on 4, and I got that image. And let's see. Let's zoom. Let's zoom on this chair, for example. So here I have that chair on the 64, and here the same size, I'm only on 29%, and this is the 100%. Okay, so I can see the table, the halls here, plants, the wall of plants here, which is really cool to see it. So you can see them really close in 100%. If I will take this, I will go back to the other image, to the one. And even let me reopen the 16 and let's zoom to that part. So you see, I cannot zoom so much. Okay, and here I really can see the plant and everything. Okay, let's zoom to this part as well. So I can really see the leaves and everything. And here, I'm missing of some data. This is a cool image of a future society, etc. It's a little weird with the way that the train are, but let's see the zoom, which is the more interesting part. This is another 512K image, 1 billion pixels. So this is the 100% for the 1x. That one is 4x. And you can see it's much better quality, etc. Let's move it to that side. This is the 64x. So if I'm going to the same train, I can see much more details and I start to see more far away things, much more far away. Okay, let's go to the largest. So let's go to the same train, same one. I'm now on 31%. So let's go to this one. And you can see the details start to be there. It's a reflection of something else. And you can see the parts of the train that here I need to really zoom and it start to be really pixelized. And here it's much more crisp. Let's do zoom out. So I really like this part, I actually have to say. Okay, let's go to the buildings. We have here that building. And you can see some data about it's a reflection of the windows, etc. Here, I go to the same building. See, I'm now on almost 150%. And I can't see that so well. Also, there are plants here. And they put me a train on the plants. Very interesting. Okay, and I can see the point of that building here. Now let's zoom out. Okay, this is a really cool thing. Now it's not fit for any image. Okay, it's not fit for everything because sometimes it doesn't do a very good job. But there are most of the cases, and I will show you now. Oh, here the train driver. Okay, I don't believe that we have plants in this part. It's supposed to be, but fine. Okay, the next image is some fantasy waterfalls, etc. Now, this is on the left, you have the 1x. Okay, that you can't see so much. Okay, now the same place is here on this is not 1 billion pixels, is around 600 million. Okay, and let's go to the tree. And you actually can see it's amazing zoom. Okay, and here it's much better compared to other images. Now, one of the key things about images and rescaling and upscaling is to make that the image is not have smooth areas. So as you have much more diversity in the pixels, much more colors, you won't see any tiles and artifacts. You will see much less of them, much less. Okay, and this is really cool. Like, this is an amazing work of the AI. Really cool. Okay, let's zoom out and let's go to this part. to the stone here. Now, here the stone is very nice, etc. I don't see anything, but let's zoom and look, we have a man. Okay, very nice. Someone that just look on in the area. Okay, you can see here the plants which are super high quality. Okay, which are around here. Let's zoom out so we'll have some orientation. Yeah, here in this part. Okay, so you actually can see a lot of data inside, a lot of data. And the data is really crisp, really good data, very high quality. Okay, let's go to the area of the water, those stones, etc. And it's really good. The 100% is really good. Really, really good. Okay. Now, this is the showcast of them. And I will show you now the upscale itself. I will give you some data about the flow itself and how I build it. So let's see. Okay, this part is actually how I made it. What is the workflow itself? And I will give you that workflow also in the description below if you want. Write me in the comments if you want to get the workflow, and I will just put it in the notes. Okay, so let's zoom a little bit. We have multiple parts of the workflow. The first part is to choose what is the actual model. So what I'm usually doing, I am taking also flex, okay, and non-flex. It can be XL or SD 1.5. Okay, in this case, I am using the XL with the add detail LoRa. Okay, now sometimes I am doing the Flux, and when I use it, and then the big upscale will be done with other models to save time. If not, it can take me like days to use the Flux. The next part is actually the tricky one. It's a very cool one. I have multiple wildcards. The wildcard is really cool. So you have a file with lots and lots of text. Okay. Now each line will have one number, and the number when it gets to the last line, it will go to the first one. Now each one of those can get a full description. Okay. It means that I can get predefined descriptions and just use them in my prompts. Okay, so I have here, like I have the cyber room, and I have let's see, I have random subjects, and I use I have also scenes. If I will do this action, this will be active, and I will have scenes now. Now after that, I will have a text generated. Okay, some text will be generated. And it will be generated and move from the original one. Let's say I copy that one here. Now it will generate a text. You will see it here, and then it will go to the AI, the OpenAI plugin, and the OpenAI plugin will generate a super detailed text phrase, as you see here. And that is the one that going to the text, to the clip encoder, to the text encoder. Okay, so I have a random text, things that are predefined, but it will take it from random order. Then it will put it in the AI. The AI with a random number, usually it's increment, with a random number will generate a new text each time. So I will never get the same image, the same description. It will go to the encoder, and then from the encoder itself, it will go to the K-sampler. Now, the size of the image is very important. You can have you have multiple ways to do it. I'm usually using that ratio advance of Mickey, very, very good node. So the thing that I do with it, I'm giving it size here, and I'm usually giving it twice the size. If I need 1344, I will give it 2 times the size. So this number here, the mult, is multiplying that value, okay? And you can see it here. I just put, so you can see the actual value. So this is the actual value of the image. And then I will generate one, which is actually x4 value, and throw it inside the ultimate SD upscaler on number 4. It means that I will get an image of 64x. This is the number of the image that I will get here. Okay. Now, the problem with this flow, if I will take the image directly from here and move it to the next upscaler, okay, it will crash. And I want 4x, I will crash. It won't work, and the memory and everything will not work. So the solution is very simple. I'm taking this image, I'm creating a load image, and after I have that upscaler saved to an image, I take the image and drag it to the load image. Then we will disable those, the K sampler and the first ultimate upscaler. Okay, and I will take the last image to that upscaler with everything, and I will generate an image directly from that part. Now, there is another small caveat here. Because I am doing random image, random text, random prompt, random everything. So in this case, after I did it in the first time, I will get here all the text, all the data that I need. Okay, so I will Control A, how to say, select it, Control C. I will go to another prompt, paste it here, and connect it to the text encoder. Okay, so the first time I generate, now I am disabling those, copy the text that generated to another node, and connect that node to the text encoder. Now, no matter how many times I will run that upscaler with that image, I will get the correct prompt, the old prompt for the original image that was created, which is super important. It means that I can now I can do trial and error, okay, on a different upscale. I can do 3, 4. I can increase the denoiser. I can increase and decrease the tiles, which are the thing that every for the artifacts. I tried it on 2000 or 2000. So sometimes it's better to do it on 1000 and 1000, which give you much better results. And if you still have issue in artifact, try 0.1 on the denoiser, etc. But this method will give you the option not to generate an image each time. Okay, because that part of the K sampler and that upscaler on my machine took 10 minutes, even 15 minutes. And this is a machine with the NVIDIA 4090, and I have around 192 gigabyte memory, gigabyte memory, more to say. And I don't have a problem with the memory. So pay attention for that part. Okay, so instead of just doing it again and again and again, you can just save the image and load the image, and you won't have the memory issue. Because I even get a memory issue on the conf because the conf itself crash sometimes. So, and another important thing, I can put here images up to 100 megabytes. Okay, so if you want to keep the PNG quality, you need to put here up to 100 a megabyte, which is around the 64x of the image. Okay? And then you will get the perfect image. Now, one more point here. If you have faces, Upscaler can work with faces. It's not doing such a great work. It can make you very big, a lot of artifacts. So when you will use it, pay attention to the size here, okay, to the tiles. Even on the first upscaler, better to have 512 for faces and stuff like that. And also here, okay, give it 0.1. You cannot give it like 0.2 in most cases. Okay, give it 0.1 because the face and the body will totally be distort, etc. Now, this is why I also have the face detailer in this part. So after the first upscale, I am giving it to the face detailer, and the face detailer will give me an image with a better face, much better face, corrected, etc. Okay, and after that, I can take that image and put it here and do the same action. But again, if this is faces, I will work with 0.1 or even 0.5 and 512, 512. And that's it. This is the entire workflow. Okay. Thank you very much. Hope you enjoy. Comment me, ask me anything, and I will see you in the next video. Bye.